All right. Oh, I have the list up now. So our first speaker will be talking about space plasma physics and science opportunities from the moon's surface.
That is very okay. Thank you very much. Thank you for invitation, and I would like to talk a little bit about space plasma, exosphere, and dust physics science opportunities from the lunar surface. And this is basically activities ongoing in Europe or under the ESA activity. And we just formed a topical team to discuss possible science on lunar surface. A little bit about history and future activities I would like to introduce. Okay, as many of you know, and around the moon, it's a really unique location to study in space plasma physics. Well, it's just an example, but it's in a wide range of an energy moon. For example, solar wind has an energy around kV, magnetic tail plasma of the Earth. Of course, it's something like 30% of the time moon is experiencing. It's about tenths of kV. And high energy particles, radiations from solar energetic particles or GCR and cosmic rays from MeV, GeV or higher is impacting. Particular interest is that, and the fact is from the fact that the moon doesn't have any atmosphere or magnetosphere, which produces a direct radiation impact on the lunar surface as well as a human on the moon. I mean, when we visit and in terms of lunar exploration. In addition, it's in a good place for space weather prediction that impact on the Earth. Sometimes or frequently the moon is upstream of the Earth, and then the prediction and assessment of the space weather that impact to the Earth can be done from a lunar surface. Previously, we under the ESA program, the gateway. Well, we investigate a similar study and space an assessment about space weather package of space weather physics in terms of an framework of an gateway. It was in 2019, a couple of years ago, we scientists in Europe formed a topical team to investigate space plasma physics and space weather studies from the gateway. Indeed, we visited a lot of topics that is relevant for plasma physics, basic plasma physics, space weather applications, as well as an interdisciplinary sciences. It's just an example. For example, a reflection of the solar wind protons as neutral atoms with energies something like 30% to 60% of the solar wind protons. Solar wind interaction with a crustal magnetic field, and it's a really interesting simulations in electron scale, as well as an association of this magnetic anomaly to the lunar surface albedo, both an optical and empirical, which is relevant for understanding the modification of an solar wind impact on the lunar surface and then magnetization. Other topics about magnetic tail or geomagnetic tail or plasma sheet dynamics, for example, plasmoid, bursty bulk flows, magnetic reconnections, those thingy that can be investigated in lunar gateway orbit. Also magnetic pose imaging that can be done by an energetic neutral atoms as well as an ultraviolet or UV, X-ray wavelengths. Escaping terrestrial oxygen from an ionosphere of the Earth is impacting on the moon, and a lot of magnetospheric oxygen are implanted to the lunar surface. So we surveyed the literatures and assessed what kind of science questions and instrumentation can address space plasma physics or space weather phenomena from the lunar gateway orbit. We concluded an example science questions and relevant instrumentation, which our previous lead of this topical team, Ianis Dandouras, is preparing a draft of this report. For example, monitor solar wind to investigate the dynamics of a terrestrial magnetosphere or lunar exosphere, surface patterning, monitor characteristics and radiations and environment, sputtering sources, monitor characterize the response of the magnetosphere to the solar wind. It's really a space weather application. Monitor solar wind interaction with the lunar exosphere, regulars and anomalies. It's also in the fundamental physics to understand magnetospheric sciences. Also in ion dynamics close to the lunar magnetic anomalies, and monitor an exosphere and the plasma sphere by remote sensing. And ambient plasma in different environments shall be characterized. Basically, we concluded that a wide range of instrumentation that can be done, instrumentation on board the gateway, if possible, can address a significant amount of sciences relevant for space weather or space plasma physics around the Earth and the Moon. But now the exploration mind moved to a lunar surface, and ESA, as well as us and scientists, a little bit redirected to this exploration mind toward the surface. And now in 2020 and afterwards, big waves toward the lunar surface exploration lead a new topical team to address physics of a plasma surface exosphere dust coupling. It is formed last year, and now it's clear that on the lunar surface, it's not only in the plasma alone that is interesting, but more interdisciplinarily, and the coupling between plasma, dust, and the exosphere, as well as the surface, is quite a big interest. So we named it as a lunar environment, and a topical team about lunar environment is working to formulate science questions and the possible instrumentations in the same way as a gateway study. Well, here and our topical team objectives is formulated like this. We will address what science questions in the space plasma, dust, and exosphere physics can be addressed at the lunar surface by an exploration program, not dedicated to exploration programs, but more in a general context here. And then we will formulate what are the measurement requirements, or what kind of measurements we need to do to achieve such an sciences. We aim to finalize two technical reports, and possibly with publications peer-reviewed to be in 2 years, or even 1 year next year in 2023. Area of focus of our group, again, it's not only in the plasma physics as we did for the gateway, but our focus would go to an interdisciplinary across and unanswered science questions in terms of dust, plasma, and surface and exosphere interactions. One example we draw here, indeed, to be proposed. We proposed an ESA's M-class mission and F-class mission, but was not accepted, unfortunately. But in a science context, here is a volatile cycle at the moon. This is just an example, but a lot of water molecule or hydroxyl is transporting from solar wind, or say is from space, and to core trap or internal structures there. So that's one. So the big picture that is that everyone is interested in for a volatile. It's highly related to an biological or say an life on extraterrestrial environment. Well, but it's not only that. Of course, example questions further is listed here. I may not.
2 minutes.
Yep, thank you. We are not going to details, but a lot of example questions we are preliminarily formulated, and we are now assessing individual questions how we can do sciences from a lunar surface. One example how we are going to do each science questions, how to assess. For example, it's a long-standing questions how lunar dust particles coupled to an electrostatic environment and lofted. We did a literature survey, grow possible measured by a surveyor and Apple 17, and possibly this is associated with a levitating dust. But then, of course, no conclusive measurements. As you know, dust have been reported by LADI. So we would like to also assess how significant it's in terms not only of science as well as a future prospect in terms of explorations. Lunar dust, of course, have a significant negative impacts. Required measurements will be formulated in the following, for example, levitating dust and the electric field near the surface. Well, another example I listed here related to exospheric sciences, and one interesting question: what are the time scales of the exospheric neutrals or volatiles? What controls the time scales? Well, similar way we did in the background sciences by literature study, identify significance and then the future prospect, and the required measurements are formulated. Okay, what we are going to do, again, the outcome of the topical team study will be archived into technical reports to ESA, and ESA will use this science knowledge as a base for the future landing project explorations. For example, in EL3, the European Large Logistic Lander. We are on the way to this report, and well, basically what we are addressing is what science questions can address in the lunar surface, and what are the measurement requirements to achieve the sciences. Thank you very much.
Thank you. That really encompassed the theme of the entire workshop. So we really appreciate it. I don't have any questions coming through on the Q&A right now, but I have a question myself. Can you explain what lunar sputtering is and what the effects it could have on lunar operations could be?
Sorry, can you repeat the question? I didn't get much.
So the lunar sputtering, could you explain that and what effects it could have on surface operations?
The lunar sputtering here, it's basically in the solar wind plasma just kick off and surface materials. That is basically not a very tenuous plasma, so I do not expect in terms of an exploration that would impact, but it's quite important in terms of an surface processing and space weathering and regress. It's more, to me, more fundamental physics.
Okay, fantastic. And you mentioned that the topic team will be putting out a report. Where do you expect that to be published and accessible?
Yes, we are going to publish it in kind of in a peer-reviewed review journal. Yeah, we will see how fast we can go ahead with that. But yeah, we aim at a final product as a publication for the public access.
All right, fantastic. And there's one more question. Can you speak to studies done on transport of regolith from a lander to the gateway vicinity? That's a good question.
That's an interesting point. We haven't considered so much about that. So far, we rather focus on robotic mission like a concept, but definitely we are going to include a human presence and a kind of a sample return science that we can address. Yeah, that's really good comment. And
Yep.
yeah, we will
Okay.
consider. Yeah.
All right. Well, thank you very much. Appreciate it.
Thank you very much.